Welcome back to the Remedify coaching program. We've got a really interesting deep dive today. It's going to be a fascinating one, I think. We're looking into the relationship between apes and humans, and you've given us some materials. It's a pretty interesting collection of you know data and opinions and different perspectives. And I think our mission today is to kind of go through all that and unpack it. What do you think?
Yeah, absolutely. I think that, you've got sources here that talk about, how things change, how living organisms change. We've got, comparisons of human DNA to ape DNA. There's some mathematical stuff in here related to mutations. We've even got some historical examples. I think it'll be a good time going through all this.
I think so too. Yeah, and you even brought up this idea of natural selection and how that all kind of plays into it. So this is going to be, I think this will be a really good deep dive. It's gonna be fun.
Looking forward to it.
Yeah, I'm excited about this one. So, maybe we can just start with like the basics here, right? So, the material you've given us kind of lays out two basic ideas right at the beginning about how all this diversity of life came to be, and you've got, creation by God, that idea, and then you've got this idea of evolution, which is powered by natural selection. So we've kind of got those two sort of foundational ideas.
Right from the start,
Mm.
you've got these two very different, I guess, lenses through which to look at all this data, and I think that's interesting, right off the bat. How we even approach the evidence, how is that affected by, the foundational ideas that we hold?
Yeah. Yeah, that makes a lot of sense. So, one of the big arguments that comes up in what you've brought here is that, for evolution to really work to create like more complex life forms, there's got to be some way to add new genetic information,
Yeah.
right? So that leads us to this idea of mutations, right?
Right.
Mutations are just they're changes in our DNA, and some of them can be bad news. Some of them are kind of meh. They don't really do anything noticeable, and some of them are thought to be good, beneficial. Like they give an organism an advantage.
So then the question becomes like, well, what's the nature of these mutations? Like, are they really can they really explain, the development of new features, new organs, new, all that kind of stuff?
Yeah, and there are a few experts cited in the material you gave me that seem to have some doubts about that. Like whether mutations can really explain the development of all the new genetic information you would need. For example, you've got Jerry Bergman. He's got a PhD in human biology, and he says that even the mutations that people think are beneficial, a lot of times what they really do is just cause a loss of function, and it's not really clear whether they're creating truly new information.
Right. Like you can lose something, but can you actually build something new and functional, just from random changes? That's the big question.
Exactly, yeah. And then you've got John Sanford. He's got a PhD in genetics, and he says something similar. He's like, look, even with these so-called beneficial mutations, nobody's really shown clearly that they create or add information in a way that we can, definitively say is new.
It's almost like you're shuffling things around, but you're not actually adding any new cards to the deck, so to speak.
Yeah, that's a great analogy. And then there's Jonathan Sarfati, PhD in chemistry, and he kind of takes that even further. He says, a lot of these examples that people give of like, quote, evolution in action, what they're really showing is a sorting or a loss of information. It's not like new information popping into existence in the genes.
That's interesting. So it's more about rearranging what's already there, not creating something fundamentally new.
Right. And we've got even more on this idea. There's Werner Gitt, his background is in physics, Bob Compton, neurophysiology, and then Jorge Fernandez, who works in pattern recognition and apologetics. They're all cited as saying, there's no real research, like real hard scientific research that shows like matter by itself can create this thing they call universal information. So I mean, it really makes you think, right? If these mutations aren't adding new information, how did all this complexity arise?
Yeah, it kind of pushes you to consider whether there's something more going on, maybe something beyond just random chance and change.
Right. Yeah, for sure. And then the material kind of goes into this idea of what it calls common sense in mutations. So it basically says, when you really think about it, like just common sense, mutations are mostly bad, right? Like things breaking down, not getting better. But then it contrasts that with the perspective that's often attributed to people who believe in evolution. They
Like
say,
that.
well, yeah, but you got to think about all the time involved, right? Like millions and millions of years. So they kind of use this vast amount of time as a way to overcome, like, the challenges of these rare beneficial mutations.
So the idea is that even if beneficial mutations are incredibly unlikely, given enough time, they'll eventually happen, and those are the ones that will stick around.
Right, right. But then the material kind of pushes back on that and says, well, what we actually see happening is mostly like rearranged information, lost information, redundant information. It's not really new stuff.
So it's questioning whether time alone is enough. Like, is time the magic ingredient that can turn, unlikely events into the diversity and complexity of life we see?
Exactly. Yeah. And to really hit that point home, they quote this guy, James Crow, who's a professor of genetics. And he said, this was back in 1997, he said that the typical mutation is really mild. Like it usually has no effect, or maybe it makes the organism a little bit weaker or a little bit less fertile. And he called that, he said it ultimately leads to, quote, one genetic death.
One genetic death. That's kind of a striking way to put it.
Yeah, it is, isn't it?
Uh,
And so the material poses this what it called a power question for you, actually. Can you show us some observational evidence, like something we can really see and test? For all this information in our DNA that doesn't require us to just, take it on faith.
Ooh, that's a good one. It's like, show me the receipts. Right. And not just the theory, but the actual observable evidence.
Right, exactly. Okay, so let's switch gears a bit and talk about natural selection. The material gives us a couple of definitions to kind of, get us started. So first, there's Charles Darwin's description of natural selection. He described it as like this constant scrutinizing of all the little variations, right? Like every day, every hour, nature's looking at all these differences, rejecting the bad stuff and keeping the good stuff.
Okay, so it's like a filter, basically. It's sifting through all the variations, and only the ones that are best suited to survive and reproduce are going to make it through.
Right, yeah. And then there's this definition from a seventh grade textbook, which is kind of interesting. It says that over long periods, natural selection can lead to evolution. And it does that by, accumulating all the helpful variations and getting rid of the harmful ones.
So both of these definitions are pointing to this idea of a gradual process where, the good stuff gets kept and the bad stuff gets tossed out.
Yeah, exactly. But then the material takes it a step further and presents some viewpoints that suggest that natural selection, it's not just this passive filter, right? It's seen by some as this really powerful force. So, for example, there's Daniel Dennett, PhD in philosophy, and Ernst Mayr, a PhD in ornithology. They're both quoted as saying that basically evolution through natural selection replaces God, like it's the explanation for, all the complexity and diversity we see.
Yeah.
And then Jerry Coyne is cited as believing that natural selection is the only way to explain how all the amazing adaptations in living things came about.
So it's going beyond just saying, natural selection gets rid of the bad stuff. It's saying that it's the driving force, the creative force behind all these incredible features we see in nature.
Exactly. But the material doesn't just leave it there. It then kind of pushes back on this idea and asks us, well, can natural selection really create things?
Right.
It points out that, like, the environment, the pressures from the environment, those aren't good or bad in themselves, right? Like whether something is beneficial or harmful depends entirely on the traits that the organism already has.
Yeah.
So it's kind of this chicken and egg problem. Like, where did these traits come from in the first place?
It's like saying, a drought is only bad if you don't already have the ability to survive without a lot of water.
Exactly. Yeah. So the material kind of goes into this idea that, maybe organisms are actually like pre-programmed or like they already have these built-in tools to deal with the challenges of their environment. And they quote Randy Guglielmo. He's got an MD and a PE. And he says that one of the key things about living things is that they're goal-oriented, like they're built to operate in their environment in a purposeful way.
So instead of being just passive products of their environment, they're active agents. They're designed to interact with their surroundings in a specific way.
Right. That's a really interesting way to think about it. Okay, so now let's jump into genetics. This is where it gets really, really fascinating. There's this very common claim that humans and chimps are only like 1 or 2% different in their DNA. You hear this everywhere, right? Textbooks, biology classes, professors, even scientific journals. In fact, they mentioned a 2012 article in Science that said there's a 99% similarity. But then they lay out these 5 facts that kind of challenge that whole idea.
Okay, this is where it gets, this is where the rubber meets the road, Like this genetic similarity is a big part of the argument for humans and apes being closely related.
Right. So, Fact number one, they point out that this whole 1% difference thing, it actually comes from way back in 1975.
Mhm.
And back then, they didn't even have the technology to do like full-on DNA comparisons.
So it was based on a much more limited understanding of the genome than we have today.
Exactly. And fact number two is that those early comparisons, they were only looking at very small, like hand-picked sections of DNA. It wasn't the whole picture.
Okay, so not exactly a comprehensive comparison then.
No. And fact number three is that the first, like, rough drafts of the full human and chimp DNA sequences, those didn't come out until 2001 and 2005. So it took a while to get the full data.
So we're talking about a completely different level of analysis once those full sequences became available.
Yeah, totally. Okay, fact number four is that in 2007, there was research that suggested the difference is actually closer to 5%. But even after that, you still saw that old 1% figure popping up in the media, like as late as 2012.
It's amazing how these ideas can kind of stick around even when there's new evidence that challenges them.
It really is. And finally, fact number five is that when you compare the entire genomes, the whole thing, the differences are way bigger than 1 or 2%. They're significant.
So the more we learn, the more we realize that the genetic differences are more substantial than we initially thought.
For sure. And they even quote Roy J. Britton, who's got a PhD in biophysics. And he did a study in 2002 where he just counted up all the insertions and deletions. Those are those indels, places where the DNA is different lengths. And just from that, he found about a 5% difference.
Just from the indels alone, 5%. That's pretty significant.
Yeah, it is. And then Jeffrey Tompkins, PhD in genetics, he did a study in 2013, and he found only about 70% similarity overall between chimp and human genomes. And he was using some really sophisticated methods to compare the DNA.
So we're talking about a 30% difference when you're looking at the entire genome with these advanced techniques.
Right. And Jay Wild, PhD in nuclear chemistry, backs that up.
Yeah.
He says that when you compare the whole genomes under the best conditions, only about 70% of the chimp DNA is similar to human DNA. So we're seeing a consistent pattern here.
It seems like that 1% figure is really, really outdated.
It really is. And just to put an exclamation point on that, they quote Brain Thomas, who has a master's in biotechnology, and he says that the real similarity is more like 85%, not 98. And he points out that there are literally millions of differences, like individual DNA letter differences between humans and chimps, something like 450 million. And he's like, look, there's not enough time, even in the 6 million years that they talk about, for all those differences to arise through random mutations.
So it's not just the percentage, it's the sheer number of differences that have to be accounted for.
Exactly. And that leads into what they call a mathematical problem for evolution, related mutations. So they start with this idea that mutations happen at a rate of about 1 in 10 million DNA duplications. That's like 10 to the 7th power.
Okay, so that's our starting point. Mutations are rare events.
Right. And then they do the math. They say, okay, what are the chances of two specific mutations, like ones that have to work together, happening at the same time? And it turns out it's like 1 in 100 trillion. That's 10 to the 14th power.
Wow, so the odds are getting exponentially smaller as you add more mutations.
Right. And for 3 related mutations, it's 1 in a billion trillion. That's 10 to the 21st power. For 4, it's 10 to the 28th power. And for 10, it's a mind-boggling 10 to the 70th power. So they're basically saying, look, it's statistically improbable that you could get all the specific mutations you would need to create, new features and new complexity.
Yeah, the math is really working against the idea that these random mutations could build up all the intricate systems we see in living things.
Exactly. Okay, so now the deep dive kind of shifts gears and looks at some what they call famous celebrities in the study of human evolution. So they start with some examples that are kind of cautionary tales, like Kiltdown Man, which turned out to be a fake, a hoax, and then Nebraska Man, which was based on just a single tooth that later turned out to be from a pig.
Right. Those are classic examples of how interpretations can go wrong, especially when you're dealing with limited evidence.
Yeah, definitely. And then they mention Neanderthals, who are now generally considered to be fully human. But then they really focus on two big fossil finds, Lucy, the Australopithecus, and then this fossil called Ida.
Lucy and Ida, two big names in the story of human evolution.
Yeah, for sure. So they go into Lucy the facts, and they list out all these characteristics, like a chimp-sized body, outturned knees, long curved fingers, a wrist that suggests knuckle walking, a cone-shaped rib cage, an ape-like big toe for grasping, an ape-like skull, a flat pelvic bone, and an inner ear that suggests she had balance like an ape.
So they're painting a picture of a Lucy that's much more ape-like than human-like.
Right, yeah. And they even quote Charles Oxnard. He's got a PhD, and he's a professor of anatomy, anthropology, and evolution. And he says that Australopithecines are, quote, irrevocably removed from human bipedalism. So, like, they weren't really walking upright like we do.
That definitely challenges the classic image of Lucy as this creature that was well on its way to becoming human.
Totally. And then they bring up Dr. Fred Spoor, who's a professor of evolutionary anatomy. He did some really detailed, say, scans of Australopithecine inner ear canals, and he found that their anatomy just didn't support the idea that they walked upright habitually. So, like, their ears say they weren't walking like humans.
That's fascinating. So the evidence from the inner ear, it contradicts that idea of them being upright walkers.
Yeah, it's pretty wild. Okay, so then they get to human evolution, IDA. And this is a cool one. So IDA is a 47 million year old fossil, and it's super complete, like 95% intact. And when it was first discovered, there was all this hype, like they called it a missing link, the eighth wonder of the world, all this stuff. But then pretty quickly it turned out that IDA was actually just an extinct lemur.
So another example of how initial interpretations can be overturned as more evidence becomes available.
Yeah, definitely. And the material uses this as an example of what they call fossil imagination, where, like, your beliefs about evolution can kind of color how you see the evidence.
Right, it's like seeing what you want to see. You're so focused on finding that missing link that you might overlook other possibilities.
Exactly. And then the material starts to wrap up by suggesting that maybe, just maybe, there's a bit of a disconnect between what's being taught in schools and shown in the media and what they consider to be the real science on this topic. And they also express some concern about the philosophical perspectives that might be shaping how this information is presented. For more resources on this topic, please visit Tyrannus Hall Bible College, THBC, at https://www.youtube.com at Tyrannus Hall Bible College, https://www.youtube.com at Tyrannus Hall Bible College.
So they're basically saying, hey, there might be some bias here and you need to be aware of it.
Exactly. And then in the last part of the material, they talk about a plan for equipping young people. It's called the CTI Strategic Plan, and it's all about helping the next generation believe in and trust and defend their faith. And a big part of that is having teachers in Christian schools and churches who are equipped to teach, about creation and how to defend those beliefs.
So it's about empowering young people to think critically about these issues and to be able to articulate their own beliefs.
Yeah, exactly. And they lay out these 6 things students must learn, which are like, knowing and sharing the gospel, understanding apologetics, being able to think critically, understanding the scientific evidence related to origins, presuppositional apologetics, and then recognizing and refuting compromise.
It's a pretty comprehensive approach to education and faith formation.
Yeah, it really is. They also mentioned this 5-day apologetics training course that happened back in 2017 at the Glorieta Conference Center. And it was for students, pastors, youth leaders, teachers, parents, anybody involved in education and ministry. And the goal was to, build an army of Christian educators.
It sounds like they're really serious about equipping people to engage in these conversations in a thoughtful way.
Yeah, they definitely are. So, we've gone through a lot here today. We've looked at all these different sources and different perspectives on the relationship between apes and humans. And it's clear that there were some big questions being asked about the standard narrative. How did we get here? What are the mechanisms of change?
Right. It's challenging us to think beyond just accepting what we've been told and to really delve into the evidence for ourselves.
Absolutely. And the material you gave me, it really pushes for a closer look at genetics. How do mutations really work? What can natural selection actually do? And how do we interpret the fossil record? It also raises this concern about, is there some bias in how this stuff is being presented?
It's urging us to be discerning consumers of information and to not just take things at face value.
Yeah, for sure. So the big takeaway here is that, to really understand these complex questions, it takes more than just accepting, surface level claims. You got to be willing to think critically, to dig into the evidence, and to consider different perspectives. We really encourage you to keep exploring these questions, do your own research, keep learning, and keep thinking.
There's so much more to discover, and the journey of discovery is really where it's at.
That's so true. And hey, if you want more resources on this topic, don't forget to check out Tyrannus Hall Bible College, THBC. You can find them on YouTube, at https://www.youtube.com at Tyrannus Hall Bible College, https://Tyrannus Hall Bible College, https://www.youtube.com at Tyrannus Hall Bible College. They've got a lot of great stuff there.
Yeah, they're a great resource for anyone wanting to explore these topics further.
Absolutely. Well, thanks for joining us for this deep dive. It's been a fascinating one.
Yeah, always a pleasure.
Thanks for listening to the Remedify Coaching Program.